Hi, 8th graders. It's Mrs. Robleski. I hope you had a good spring break and are ready to go again. We're just going to do some review of how to solve systems of equations before we actually go ahead and take our benchmark and get graded on some of these solving systems. So I'm just going to quickly review. I would like for you to have kind of a paper that you're trying to solve some of these problems on. And then you're going to be pausing the video, trying to figure them out as we go along and seeing kind of how you're doing. I am open for office hours or even after this lesson for you to ask questions, especially if there's one that you were not sure of and want me to go over that review before you go ahead and take the benchmark. So I'm just going to get started with, I kind of gave you a little hint about how to solve some of these. On the benchmark, you get to use whichever method is best for solving the system. So when I look here, it says solve using substitution or graph it. If you have graph paper, you could certainly graph this one. You could also substitute the y in for the y, which we then would call that equal values. You have y on one side and y on the other side. So I'm just going to go through and do both methods, and then you can see which one would be easier for you. So right over here, if I circle the slope, so we look, that would be -1. That would be right in front of the coefficient there. And then here we have -2. So they have different slopes. So right away, that tells me that it's probably not going to be infinite. It's probably not going to be no solution. And then here would be my y-intercept. It's going to start at 0, 3. And then here it is also going to start at 0, 3. So if I go over to here and how I graph that, I can see that I just kind of sketched it real clearly, or not real clearly. I'm going to try to make it clear there. So I kind of just sketched it, both starting at 0, 3. One is going over 1, down 1, over 1, down 1, not a very steep slope. And the other one is going over 1, down 2, over 1, down 2. And then where they intersect would be my solution point. So my solution is 0, 3 is where they actually intersect. So I could go about doing it that way. If you would prefer, you could have made the y, the 3 minus x on this side, and the -2x plus 3 is also equal to y. I could then go ahead and solve my equals values. So I get kind of cross out the x there, and I get 3. I get -1x plus 3 on this side. I can go ahead and take away the 3 on this side, take away the 3, and I end up with 0, which is exactly what I got over in my graphing. And then I go ahead and plug that back in. So I go 3 minus 0 is 3. So my x is 0, my y is 3. So my solution point, again, is 0, 3. So I can solve this by doing different methods. I'm still going to end up with the same system, how I get the answer, 0, 3. So I'm going to go ahead and have you kind of try this problem out on your own. Pause the video at this time, and I want you to try to figure out how to solve this system. If you wanted to go ahead and graph it, you could, but again, it's not in the y equals mx plus b, so that might not be the best method. I'm looking, it looks like it's lined up, so maybe elimination would be the best, but the coefficients are not the same, so I'm going to use that multiplication to get the same coefficients and see if I can solve that. So I want you to go ahead and pause the video at this time, see if you can figure out this answer, and then unpause it and continue on checking the answers as we go along. So hopefully you've solved this and you came up with a solution. They do intersect. And I went ahead and did my work over here so you can kind of check your work. I multiplied the 4x by 3, so I got 12x, I got 9y, and then I got 60. Remember to do it to everything. Same thing over here. I multiplied this by 4, and I got -12x plus 8y equals 8. And then I went ahead and I added them. So I kind of eliminated the -12 and the +12 are opposite coefficients. So that equals 0. 8y plus 9y is 17y. 8 plus 60 is 68. Divided by 17, and I end up with 4. Now remember, we can't have just one answer. We need the other one. So then I go back and plug it into my original equation. It does not matter which one. So I plug it back in, and I went 4 times 4, or I had the 4x, excuse me, I had the 4x plus the 3y So the y is 4 equals 20, and I'm trying to solve for x. So I go ahead and continue on, and I end up with 4x equals 8, x equals 2. So my solution to this one is 2, 4. That is where they would intersect. We're going to do one more here, and I want you to, again, pause the video and see which method would be the best for you to solve this one. So here it is, noticing that it is in the y equals mx plus b, so I could go ahead and graph it. I could also say I could use elimination because they are lined up and try to get the opposite coefficients or the same coefficients. Or I could use substitution where I have y equaling this, and I could put that on this side, and y equals this, and y equals this, so then I'd have equal values, and I could solve it that way. So I'd like you to pause the video at this time, choose a method, or if you wanted to, you could do both, graphing and elimination or graph and substitution. Either way you do it, you should get the same answer. So I want you to go ahead and pause it at this time and see what you get for your answer. All right, so we are back and we're going to check our answers. I'm going to go through them very quickly because we should be at that point where we know how to do this. And this is just a review for us. So I did the substitution method, where I put the negative 3x minus 7 on the one side because that was the y, and the x plus 9 was the other side because that was the other y. I go ahead and subtract the x, and I end up with negative 4x equals 16. So I end up with x equals negative 4. I'm not done yet. I take this x equals negative 4 and I just plug it into already what I had, x plus 9. So negative 4 plus 9 is 5. So my answer is negative 4, 5. If you didn't want to go about doing it that way and you wanted to graph it, over here I circled my slope. And this is my starting point, my y-intercept. So I start at 9 and I go over 1, up 1, over 1, up 1, over 1, up 1. Again, I start at negative 7, so way down here for my y-intercept, and I go over 1, down 3, over 1, down 3, over 1, down 3. The hard part about this one is you really do need graph paper instead of sketching it because I'm not quite sure where that line of intersection point is. It does look like it is negative 4 and 5, but I'm not certain because I kind of sketched it. So that's a little harder to do unless you have actual graph paper. But that would definitely be a method if you had the graph paper. Elimination. Some of you said, well, I can't take away the y and the y. You can do that. It's a little weird that we haven't done a lot like that, but you could end up with a 0 equals negative 4x plus negative 16. To get rid of that negative 16, you add 16 to both sides, and you end up with negative 4, and then you would plug that back in, negative 4 plus 9, to get the 5 the same way. So again, those are all showing solutions. We will continue on practicing the no solutions and infinite solutions. That is the next video that I would like for you to watch.